Welcome to my channel Simple Concepts by DJ. Today we are going to see nodal analysis where in a circuit three different sources are being used. So let's get started. I'll draw the circuit diagram first, then we start with the expression. Fine. So here I have three different resistors. In between I have a battery. Here a resistor and another resistor. So this resistor is called as R1, this is called as R2, and this is called as R3. Now here I have a battery which is called as E1. Again in the center there is a resistor. A resistor has been connected. Here again a resistor has been connected. Here a battery is being connected of EMF E2. Now this is the node point. This node point is being connected to the ground. So again I am connecting this point, that is the negative terminal of the battery, to the reference node. Similarly the negative terminal of the battery with EMF E2 is connected to the datum, that is the datum node. So now I am going to mark the resistors R1, R2, R3. This is E1, E2. This battery is E3. This one is R4. This one is R5. Right? So you have, this is the circuit. Now you need to mark the direction of currents. So let us assume that a current I1 flows here, a current R4 flow here, a current I2 flows here, a current I5 flows here, and a current I3 flows here. So you have two different nodes. This is node A, this is node B. This is node A and this is node B. The voltage that is being developed in these nodes are denoted as VA and VB. Right? So at node A, so we consider node A first. Node A. Since this is a nodal analysis procedure, we need to consider only Kirchhoff's current law. If this is a loop network, means we need to follow Kirchhoff voltage law. So here we need to follow only the current law. So node A, at node A we need to apply the KCL formula. So KCL will be I1 minus I2 minus I4 equal to 0. This is I1 minus I2 minus I4 equal to 0. So now I am going to find the value of I1. I1 will be E1 minus VA. E1 minus VA divided by R1. This is the value of I1. Similarly, the value of I2 will be The value of I2 will be, you have two different nodes here and you have a battery supply and EMF source in this branch. So what you need to do is I2 will be VA minus VB, VA minus VB, and the current is flowing from the negative terminal to the positive terminal of the battery. So this E3, EMF E3 should be taken as positive, plus E3 divided by the resistor R2. So this is the value of R2. Now we need to find the value of I4. The value of I4 will be equal to VA. This is A. In this node a voltage has been developed. So this is being denoted as VA, that is voltage at the node A. So I4 will be the ratio between the voltage and the resistance in that particular branch. So in this branch you have a voltage VA, you have a resistor R4. So the ratio between the voltage VA and the resistor R4 will be considered to be the value of I. Therefore I4 will be VA divided by R4. So it will be VA divided by R4. So I have found the value of three parameters, that is I1, I2 and I4. So three values I had found. So I'm going to substitute all these values in this expression which we had formed in the initial stage. So I1 will be E1 minus VA divided by R1 minus VA minus VB minus VA minus VB plus E3 divided by R2 minus I4 will be minus VA divided by R4 equal to 0. Now we need to split the terms. Okay. So it will be E1 divided by R1 minus VA divided by R1 minus VA divided by R2 plus VB divided by R2 minus E3 divided by R2 minus VA, which is divided by R4 equal to 0. Now I'm going to segregate each and every term. I'm going to club I'm going to club all identical terms. So I have VA, this is minus VA, taking minus VA outside, I'll be getting 1 divided by R1 plus 1 divided by R2 plus 1 divided by R4 plus 1 divided by R4. So minus VA. So next I have VB plus VB divided by R2. VB is divided by R2. So I have 3 VAs, 1 VB, and finally I'll be having plus E1 divided by R1 minus E3 divided by R2 equal to 0. So 1, 2, 3, 4, 5, 6 terms are there. 3, 4, 5, 6. So totally I have 6 terms. So this is the equation. So what I can do is, I can simplify it. VA into 1 divided by R1 plus 1 divided by R2 plus 1 divided by R4 minus VB by R2 minus E1 by R1 plus E3 by R2 equal to 0. So the negative sign is converted into positive sign. Similarly, these two positive sign will be converted as negative, and one negative sign will be represented as positive E3 by R2. So I'm changing the signs. So this is the expression for equation number 1. So so there are totally 3 nodes are there: node A, node B, and this is the reference node. So the formula is n minus 1. So 3 minus 1 is 2. 2 is the total number of equations which we can form in this resistive network. So already we have formed one equation. Therefore the second equation will be considering node B. So at node B. So I'm going to consider node B. So if I consider node B, at node B I'm going to follow this current law. So when I apply current law at node B, it will be incoming currents will be taken as positive. So that will be I2 plus I3 plus I3 minus I5 equal to 0. So what is I2? I2 we have already found the value. So remaining I3, what is the value of I3? I3 is nothing but you have two different sources, voltage source here. One is E2, another one is the voltage that is being developed in the node B. Therefore, I3 will be equal to E2 minus VB. E2 minus VB divided by E2 E2 minus VB divided by R3. It will be R3. E2 minus VB divided by R3. What is I5? I5 will be VB divided by R5. It will be VB divided by R5. I5 will be VB divided by R5. So we have obtained the values for all the individual parameters in this equations. The next step is that we need to substitute all the values which we had obtained. So I2, what is the value of I2? I2 is nothing but VA minus VB plus E3 divided by R2 plus I3 value is plus E2 minus VB divided by R3 minus I5 is minus VB by R5 minus VB by R5 equal to 0. So now we need to split the terms. So it will become VA by R2 minus VB by R2 plus E3 by R2 plus E2 by R3 minus VB by R3 minus VB by R5 minus VB divided by R5 equal to 0. So now I have three different types, three terms in VB. So what I'm going to do is VA by R2. I have only one VA. So next minus VB, I am taking it outside. So the terms in the bracket will be 1 by R2 plus 1 divided by R3 plus 1 divided by R5. This is the value of VB. VA, this is VB. So the next is plus E2 by R3, E2 divided by R3 plus E3 divided by R2 equal to 0 plus E2 divided by R3 plus E3 divided by R2 equal to 0. So this is equation number 2. So I had formed two different set of equations for this nodal analysis, which consists of three different sources, E1, E2 and E3. So in the previous part we were seeing a circuit, a resistive network with two different sources, two different voltage sources. In this circuit we are seeing a resistive network which consists of three different voltage sources. So when we have three different voltage sources, we will be having two equations. These are the two equations. Okay, this is how we need to frame two different type of equation in nodal analysis with sources. Okay, thank you all for watching this video. I hope you like this video. Please do subscribe for more interesting and upcoming videos. Thank you all.